Hello everyone. In this example, we are asked to express the expression sine squared of x times cosine squared of x in terms of just the first power of cosine. Essentially, what we are being asked to do in this example is to reduce the power of our expression until we can rewrite it in an equivalent way, just using first powers of our cosine function. And well, to reduce our powers, we're going to use our power reducing formulas that we see here on our board. And so our starting point is the expression we are given, sine squared of x times cosine squared of x. Well, we can use our power reducing formulas over here for each of these and initially write them as a product of some expressions using that first power of cosine. So let's go ahead and do that, but unfortunately we won't be done after that first step. Alright, so we know from our power reducing formulas that sine squared of x is the same as 1 minus cosine of 2x over 2, and cosine squared of x is the same as 1 plus cosine of 2x all over 2. But unfortunately, this does not accomplish our goal because we haven't actually written it in the first power of cosine. Sure, we see cosine not raised to some powers here, but if we expand this out, it would give us a cosine squared power, so we're not quite done. That'd be kind of like taking the original expression and writing it as like sine of x times cosine of x times cosine of x. Sure, you have it written as a single power of cosine there, but that's not really in the spirit of the problem. We don't want, after we expand everything, to have any higher powers of sine or cosine. So we're not done yet, but our next step is to expand what we currently have. And so there's quite a few ways to simplify this algebra we are about to do. We can notice that both of these fractions have a denominator of 2, and when we multiply fractions together, we multiply their numerators and their denominators together. So that's going to give us a new denominator of 4, but I'm going to go ahead and pull that denominator of 4 all the way out of this product and bring it out as a factor of 1/4. So now we're going to have 1/4 times the product of our numerators, 1 minus cosine of 2x times 1 plus cosine of 2x. That's that really common pattern called the difference of squares, and it simplifies pretty nicely to just 1 minus cosine squared of 2x. So we've made some progress. This is a better spot than we started in, right? When we started, we had like 2 powers of sine x times 2 powers of cosine of x. We can almost even think of that as like a 4th power type of polynomial thing. And now we've got it down to just a single second power of cosine or just a second power expression altogether. So we're going to have to iterate our process or go through this one more time to finish reducing our power. And so now for this next step, we're going to have to use our power reducing formula one more time, but we have to be really careful in its second application because now we're not applying it to cosine squared of x, but to cosine squared of 2x. So how is our formula going to have to be adapted when the input of our argument has changed? Well, basically, whatever substitution we make on the left-hand side of our formula or identity, we have to also make on the other side. So if this theta gets doubled or replaced with a 2 theta, then this theta is going to have to get replaced with a 2 theta as well. So that'll give us 2 times 2 theta or 4 theta in general. And so that's how it always works with these power reducing formulas. Whatever the angle is on the left-hand side or in the squared version, it always gets doubled at the cost of reducing that power. So if this was like a cosine squared of 3 theta, we would then write it in terms of cosine of 6 theta, or twice that starting angle. So our cosine squared of 2x is going to end up looking like 1 plus cosine of twice that, so cosine of 4x all over 2. And so we have to be very careful with all these parentheses and brackets floating around, make sure we distribute everything properly and combine some like terms. And so we can think of this quantity inside the brackets coming from our power reducing formula as 2 fractions, 1/2 plus cosine of 4x over 2. We can then do 1 minus that 1/2. 1 minus 1/2 gives us positive 1/2. We have to also distribute that minus sign or that negative to our cosine expression. And that'll give us negative cosine of 4x over 2. Now, one last step, and this one might not be necessary, but just for fun, we can redistribute that factor of 1/4 that we pulled out in the beginning. And that gives us 1/8 minus cosine of 4x over 8. So sine squared of x times cosine squared of x, written in terms of the first power of cosine, is equal to 1/8 minus cosine of 4x over 8. So at the moment, this is really just an algebra and identity exercise for us, but when we get to integral calculus, stuff like this will be very helpful and necessary. when we talk about integrating some of our trig functions, integrating sine squared times cosine squared is very, very difficult. But if we rewrite it as 1/8 minus cosine of 4x over 8, then we're going to find that it's actually much, much easier to integrate.